Hey everyone, have you ever stopped to think about something we experience literally every moment of our lives but can't actually see? I'm talking about sound. Well, in this explainer, we're going to peel back the curtain on sound waves and break down the physics into something we can all see and, really understand.
So, let's kick things off with the big question, right? What does a sound actually look like? I mean, it's invisible. But what if I told you scientists have figured out a way to visualize it, and by the time we're done here, you'll be able to see it too? All right, so here's our game plan. First, we're going to look at the basic anatomy of a wave. Then we'll figure out how you can actually see something invisible, like sound. After that, we'll connect those pictures to the science of loudness, and finally, we'll touch on a few other things that change what you and I hear.
Okay, let's dive right in. Before we can talk about sound, we've got to get to know the basic parts of any wave. Think of these as the fundamental building blocks for everything we're going to cover.
First up is amplitude. And honestly, the easiest way to think about this is just the wave's height. It's a measure of its intensity or power. It's how far the wave goes up or down from its resting middle position. And since it's a physical distance, we measure it in meters.
Next, we've got the time period. This one is all about, well, time. It's simply how long it takes for a wave to do one full cycle, to go all the way up, all the way down, and get right back to where it started. So naturally, its unit is the second.
And that brings us to frequency. Now, this is basically the flip side of the time period. Instead of measuring the time it takes for one cycle, frequency asks, how many cycles can we cram into 1 second? We measure this in something called hertz. So, if a wave has a short time period, it's going to have a high frequency. Makes sense, right?
And our last building block is wavelength. So if time period measures the duration of a wave cycle, wavelength measures its physical length. It's the distance from the top of one wave, its peak, to the peak of the very next one. And just like amplitude, because it's a length, we measure it in meters.
So, let's do a super quick recap. We've got our 4 key ingredients: amplitude, which is the wave's height or power; time period, how long one wave takes; frequency, how many waves happen per second; and wavelength, the physical length of one wave. These 4 things are basically the DNA of any wave. Okay, so now we have these 4 abstract concepts, but how in the world do they help us see an invisible sound wave? This is where we need a visual tool, and for scientists, that tool is a simple graph.
Now, scientists mainly use 2 kinds of graphs to do this: a displacement-time graph and a displacement-distance graph. Yeah, they sound almost the same, but trust me, they show us 2 completely different but equally important pictures of the wave.
So here's the best way to think about the difference. Imagine you're just watching one little cork bobbing up and down in the water. A displacement time graph is like a chart of just that one cork's movement over, say, 10 seconds. But now imagine you take a camera and snap a photo of the entire lake at one exact moment, freezing all the ripples in place. That's a displacement distance graph. It's a snapshot of the whole wave's shape in space.
Okay, now for the part where this all clicks into place. We've got the theory, we've got the graphs. So let's connect one of those wave properties directly to something we all experience every single day: the loudness of a sound. For this next part, we are going to zero in on just one thing: loudness. What is it in the physics of a wave that makes one sound a quiet whisper and another one a deafening roar?
And here it is. The answer is beautifully simple. It's all about amplitude. A sound wave with a low amplitude, that shorter wave you see on the left, is what our ears hear as a soft sound. A wave with a high amplitude, that taller one on the right, is what we hear as a loud sound. It's really that direct a connection.
So you're probably thinking, okay, got it. High amplitude equals loud sound. Easy enough. And you're mostly right. But as it turns out, amplitude isn't the only thing that affects how loud we perceive a sound.
There are actually 3 main factors at play here. Number 1, and the most important, is the physical amplitude of the wave itself. Number 2 is how far you are from the thing making the sound. And number 3 is a little more personal: the sensitivity of your own ears.
First, let's just lock in the big one again: amplitude. This is the engine. This is the raw power of the sound. If all other things are equal, a wave with a bigger amplitude has more energy, and it's always going to sound louder. That's the core rule.
But then, of course, there's distance. And this is just intuitive, right? When you walk away from a speaker at a concert, the music gets quieter. The further the sound wave has to travel to get to you, the more its energy spreads out, which means its effective amplitude is lower by the time it reaches your ear.
And finally, we've got the human element, the wild card, the listener.
Our ears are not perfect scientific instruments. What sounds totally fine to you might be painfully loud to someone else, or maybe they can barely hear it at all. Loudness is, in the end, a pretty subjective experience. So, let's just bring it all home. We started this whole journey by breaking a wave down into its basic parts. Then we saw how scientists use graphs to make that invisible wave visible. And most importantly, we made that crucial connection. A wave's amplitude is what drives its loudness.
And that leaves us with one last, really interesting question to think about. We've clearly established that amplitude controls loudness. But what about those other properties we learned about, like frequency? If changing a wave's height changes its volume, what do you think happens when you change how fast it wiggles up and down? What does that control? Something to think about. Thanks for watching.